My name is Tom Corcoran. I'm a solution architect with Red Hat, and from my accent, you can probably tell I'm not from Australia. In fact, I made my way the long way here via London, Barcelona, New York, and finally settling in Sydney 2 years ago. For fun, I like to skydive and I like to kite surf, and like any good Irishman, I like to have a beer. But along the way in Barcelona, I joined a company called 3Scale API Management, and that's how I'm actually with Red Hat right now, because Red Hat bought 3Scale. So that's me out of the way. Today we're going to talk about three emerging technologies that are garnering a lot of interest at the moment: operators, service mesh, and serverless. And we're going to talk about how our enterprise Kubernetes distribution, Red Hat OpenShift, adds quite a lot of value onto the open source versions of these three technologies. So to begin with, operators, which are the most mature of the three technologies, will show you how they bring agility and efficiency to both your developer and your infra ops teams through their ability to provide ongoing management and maintenance of complex containerized applications. We'll talk to you about how Service Mesh frees developers from the burdens of managing microservice traffic flow, and also adds visibility and control through a neat abstraction to administrators, cluster administrators, through the Service Mesh capabilities. And we'll also talk about new serverless capabilities and how they can open up new workloads through their powerful eventing model, and that can scale back down to zero at idle times, radically reducing infrastructural costs and other benefits as well. So let's start with operators. Who here has read the book, The Phoenix Project? So quite a number of you have read it. Well, for those who haven't, it's a seminal work of fiction on the transformational power of DevOps, and how that power is extended into a failing IT organization that's actually threatening to bring down the entire organization. In that book, there's a character called Brent. Brent is found, he's the type of guy who's found in a lot of IT organizations. He's the guy, if the proverbial bus hit him, basically it would have a calamitous effect on the entire IT organization, such as his unique and unrivaled knowledge of how the applications in the organization work and interact. That's a parallel with operators. Operators encode human knowledge that's required to manage these complex applications on an ongoing basis, and how those systems work and interact. They reduce reliance on IT superstars like Brent. So what they do is they encode the human knowledge required to install, upgrade and patch, recover from failure, and tune applications and services on an ongoing basis. They basically execute these tasks automatically. They're in constant watch of the current state of the system and in comparison with the desired state. And if those two differ, they bring the current state back to the desired state. They're Kubernetes native, so they'll run on any Kubernetes cluster, not just OpenShift. And they're designed to automate routine tasks away from your talent and free them up for more meaningful work. So the operator framework consists of three constituent parts designed to provide a streamlined and uniform way of both writing and managing operators. So first of all, the operator SDK, or software development kit, makes it easy for independent software vendors to create operators without any specialized knowledge of the underlying Kubernetes APIs. The operator lifecycle manager is basically a way of managing lifecycle versions and their dependencies on the cluster, enabling, for example, different versions of operators to exist, say for different teams on who are using the cluster. And finally, operator metering provides metrics collection, usage statistics for administrators, bringing critical awareness to them on resource utilization with regard to operators on the cluster. So say I want to write an operator. I might be an independent software vendor, or I might want to write an operator for my in-house application. I have three choices. I can use the Helm SDK, which is the simplest. Basically allows you to use Helm charts to create your operator. Secondly, you can use Ansible playbooks and unleash the full power of Ansible in order to create that operator. And thirdly, the most sophisticated type of operator is the Go operator. So with these three SDKs, you get skeleton code, and you just add on your particular implementation, and it abstracts away the underlying complexity of the Kubernetes APIs underneath. So developers that are building operators for their applications are encouraged then to contribute to the community-based operatorhub.io. So the same way that Docker Hub is a community de facto location for Docker images, operatorhub.io is the community location, the default one, becoming that default now for operators. Operators are also fully supported in OpenShift 4. In fact, the OpenShift installation process with OpenShift 4 has been made vastly, vastly simpler through operators. About 40 operators that are working underneath the installation of an OpenShift 4 cluster. Red Hat OpenShift also offers an operator certification program to independent software vendors. So it's a rigorous testing and verification process. So when an independent software vendor is certified, it allows consumers of that operator much greater assurance, faster time to value, and expedited application deployment and configuration. Let's take an example of an operator use. Ticketmaster use a Prometheus operator. Basically, they manage hundreds of Prometheus instances across dozens of clusters. And this extends not only into the management of the Prometheus applications, but the underlying cluster configuration, operating systems, and services across these dozens of clusters. It radically reduces the effort on the human operators for managing these and results in a much more efficient and stable operation of Prometheus for Ticketmaster. And it also frees up time for engineers who are consuming Prometheus and then, in their development phases and making more opportunity for them to innovate in their daily work. So next we're going to talk about service mesh. What is a service mesh? It's been defined as a dedicated infrastructure layer for managing service-to-service communication. With OpenShift Service Mesh, it's based on the upstream Istio project. It allows administrators to control microservice traffic, including things like fault injection, canary releases, circuit breakers, and a lot of other kind of capabilities. And importantly, it takes these responsibilities away from the realm of the developer and into the responsibility of the cluster administrator where it really belongs. Service Mesh requires no code changes other than the optional removal of the traffic management code that may be there already. It's not mandatory that you remove that, but you can. And once Service Mesh is installed, which is very easy using the operator, it's a declarative process as to which microservices are under control and what controls are applied to those microservices. It uses a lightweight proxy called Envoy. It's C++ based. It was created by Lyft, which is the competitor of Uber. It's very lightweight. It's called a sidecar proxy, and it has pretty much negligible performance impact. It's so lightweight. So in addition, OpenShift Service Mesh also adds tracing and observability. So with microservices, calls from one microservice to the other are typically across the network. Unlike previously with monoliths, calls from service to service were typically in memory. When they go across the network, a lot more can go wrong, necessitating the requirement for much better tracing and visibility. And also with Red Hat Service Mesh, we're extending the control and visibility into the API layer through a 3-scale API management Service Mesh plugin, effectively allowing you to augment Service Mesh control by plugging 3Scale into the service mesh architecture and giving that extra layer of security, especially around the APIs. So why would I need a service mesh? Let's take this example here on screen. I've got version 1 on the top, and I've got a Java backend. And I want to release a new version with a Go backend in place of that Java backend. But I don't want to just go ahead and release it out into production. Rather, I want to send 5% of my traffic to my new version and just to test out how it performs. You can get very sophisticated as to, what that percentage, what that 5% is based on. It can be based on incoming request headers. It can be based on the originating IP. It can be based on the browser that's used. A lot of different other factors. So that's very powerful. Another thing that Service Mesh gives is access policy. So, for example, you might have Service A allowed to talk to Service B, but only 1,000 times per hour. Service A is not allowed to talk to Service C at all. So these kind of declarative controls are possible with Service Mesh. And importantly, there's no code involved in this. It's all declaratively. In my former life as a Java developer, I used Netflix Hystrix for circuit breaker and traffic control, and it was complex and error prone, and I really could have used a service mesh back then. So, as I say, Red Hat Service Mesh expands the capabilities beyond Istio to include some functionality that's necessary to operate a service mesh in an enterprise-ready way. So you can see on the right, you have Istio at the center and the two visualization capabilities, Grafana and Prometheus, that are normally associated with Istio, are obviously available. But what we do is we add extra visualization capabilities. Jaeger for distributed tracing and Kiali for topology visualization. So with Jaeger, I get this distributed, with Service Mesh, I get this distributed tracing tool, Jaeger, to enable me to analyze my latencies. So say I have one call that has, within its call, it has microservice A calling C, calling B, calling C. And I have a latency issue. Without a distributed tracing tool like Jaeger, it can be difficult to basically isolate where the problem is. With Jaeger, you can see how long A took, how long B took, and how long C took, and then you can drill into the problematic one and fix the problem. Another tool that you get is Kiali. It allows you to visualize the topology. You can see how services are communicating with each other. Are we having any communication problems? What percentage of each service and each version of each service is receiving the traffic? Allows you to watch the flows in real time going through the service mesh. So these two tools, Jaeger and Kiali, added on top of the Istio service mesh, make it much more enterprise ready. And of course, they're all deployed using an operator, so its installation and ongoing maintenance is greatly simplified. So I'm going to play a demo of that example I gave you earlier. It's going to be a canary type release.
Welcome to the OpenShift Service Mesh demo. You can see the microservices we'll use. A gateway microservice, which calls our partner microservice, which calls our catalog microservice. We're introducing a new version of our catalog service, but we don't want to release it all in one big bang. Rather, we want to use Service Mesh to first send 10% of our traffic to it in a canary type release. Then, when we're happy with the results and the conversion rates, etc., on version 2, we'll then send all of our traffic to version 2 and we can retire version 1. All of this traffic will be visible using Kiali. In my terminal, I'm going to auto-generate traffic. As I have two versions and I haven't yet applied any service mesh rules, it's going to alternate between version 1 and version 2. And this is reflected in Kiali above. So the first thing we do before we set up any of our production tests is to send all traffic to version 1. because we're not yet ready for version 2. And we'll use an Istio virtual service that's going to do that and send all traffic to version 1. So we'll just apply that here. And you can instantly see over on the left, all traffic is being sent to version 1. It will take a moment for Kiali to update and reflect that. It is now showing all traffic moving to version 1. So when we have our tests in place for version 2, let's use the service mesh to send just 10% of our traffic to version 2. Again, we'll replace our virtual service. It just sends 10% of traffic to version 2. In a moment, Kiali will update to reflect that. Kiali is now sending 10% of traffic to version 2. Now assume that our tests are positive and version 2 performed better than version 1. Let's use service mesh now to send 100% of our traffic to version 2. Again, we're going to replace our Istio virtual service as follows. After a couple of moments, all of our traffic is going to version 2 and we can retire version 1. So in this demo, we've seen how OpenShift Service Mesh can be used to control and visualize Canary releases. Just one of Service Mesh's many traffic management capabilities. Thanks for watching.
So in this example, we just use a randomized sending of our 10% to our new version. But like I say, we could be a lot more sophisticated as to what the characteristics are of the requests that are going to the new version. So next I'll briefly talk about serverless. So we regard serverless as an architectural evolution. In fact, so traditionally we've had many services bundled into a single monolith, which has evolved into breaking out those into microservices, necessitating the need for service mesh, for example. But even in this classic microservices architecture, at times of idle times, times of no traffic or low traffic, the microservices are still running, they're still up, they're still consuming resources. Nowadays, we're evolving towards single action functions that are spun up on demand, on invocation, scaled down to 0 in times of idle traffic. The vehicle that we're bringing serverless to OpenShift is Kubernetes Knative. There are a lot of benefits of Knative-based serverless technology. First of all, very importantly, it removes infra concerns from developers. They only need to talk about or to think about code. Ashish earlier today was talking about the fact that we want to make developers 10 times more productive. This is one of those ways. Basically, all they need to think about is writing code. Also, it can scale up on demand and scale back down to 0. This has benefits in terms of resource utilization and infrastructure cost containment. And it also provides a powerful eventing model. So you can consume events from, say, Kafka or any number of other event sources, allowing the administrator to stipulate that on receiving event X, OpenShift should spin up to 2 or 3 instances, for example, of the particular container and then back down again. And of course, since Knative is built on top of Kubernetes using the Kubernetes APIs, it's not tied to OpenShift, which basically aligns and adheres to Red Hat's vision of avoiding vendor lock-in. And obviously then also with the operator model, as the components change, the pieces of Knative evolve over time, we can easily update them and manage them on an ongoing basis. So at Red Hat, this is something we're increasingly moving towards, this serverless models when it comes to eventing and serving. So for example, we're currently working on a serverless CI/CD engine, Kubernetes-based CI/CD engine called Tecton. It's already available in dev preview, I believe. Watch out for that next year when it goes GA. And that's a kind of example of how we're embracing this serverless going forward. So to recap, we looked at operators, service mesh, and serverless. We saw how operators allow developers to consume complex applications without detailed knowledge of those applications or their architectures. As we can see with Prometheus at Ticketmaster. We also saw how service mesh allows the traffic management concerns to be removed from the responsibility of the developer, rather allow them, create tools to allow them to use those traffic management capabilities, and to place those concerns, that responsibility, into the hands of the administrator where they really belong. We saw how serverless will allow basically make the infrastructure invisible from the developers, allowing them to spend much more time of their time coding, and also with major efficiencies on resource utilization as it can scale back down and cut down on costs. So that's really it for me. We've got some next steps here. You can come out and speak to us at the booth, arrange a workshop or a discovery session, and I'll be hanging around here for a couple of minutes. If anybody has any questions, feel free to come and talk to me. Thank you.